Okay, today continue. Good afternoon. We're going to learn the questions. And the question I gave you homework. I gave the question homework as homework. Okay, we do questions on the Form 4, Form 4 homework questions, and please go through these questions. The following will carry out simultaneously. The heater in set A, you switch on, the clock is started, empty beaker and place under, fill each of the two filter funnels to collect the water from the melting ice. After 2 minutes, the beakers are taken out and the masses plus the contents are measured. Following are the readings obtained. The following are readings obtained. Okay, the power heater is 96 watt. The time of purpose of having control set. The time power is for 2 minutes. Mass of water collected in set A. After 2 minutes, 38 gram. Mass of water collected in set B is after 2 minutes. 6 minutes. 6 gram. Define specific latent heat. Okay. Okay, now this question I will explain to you. Set A. Okay, this is beaker. Okay, set A. This is the tunnel. What we call funnel. This funnel ice cubes, and there's a wire joule meter. Joule meter means connected to electricity. Connected to electricity is the set A. So the water is on water dripping. So these ice cubes, and a joule meter connected to electricity. So heater, another word heater. The heater. Okay, the heater. They put heater. The heater connected to electricity. Joule meter is something like a electric board. So joule meter connected heater. The heater is connected to electricity. As a result, heater produce heat, and the heat melting the ice. The ice, we got it. Beaker set A. We got it set A. Okay, set B. Okay, the set B, they put ice cube, but the heater, they put heater. But heater is not connected. It's not connected to the joule meter or heater or electricity. It's set B. Set B also, the heater, set B heater is not connected to electricity. That means the heater cannot produce heat. But however, the ice melts. Okay, this is set A and this set B. This set B is a control set. So they put the same thing, same set. Funnel, ice cubes, beaker, the heater, both also heater. But set A, heater connected to electricity. Set B, heater is not connected to electricity. So that means set B, heater doesn't produce heat energy because it's not connected to electricity. But set A, yes. It's connected to electricity, joule meter. So the heater produces heat energy. Okay, that's an A. Okay, first of all, define specific latent heat of fusion. Okay, latent heat of fusion means quantity of heat needed to change 1 kilogram substance from solid to liquid without changing temperature. Okay. Define specific latent heat of fusion means quantity of heat needed to change 1 kilogram substance from solid to liquid phase, to solid to liquid state without change in temperature. Without change in temperature. What is the purpose of having control set? This is control set. Set B is a control set. Control set. What is the purpose of having control set? What is the purpose? What is the purpose of control set? Okay. What is the purpose of control set? Okay. Control set, listen to me. Control set also melt ice. Set A also melt ice. But set B, to find out, the answer is question number 2. To find the mass of ice melted due to heat from surrounding. Due to heat from surrounding. They want to find the mass ice or melted due to heat from surrounding. Due to heat from surrounding. Because the set A, 2 type heat. Surrounding also got heat. Surrounding also got melt ice. Surrounding got heat and the heat from heater. The heat from heater and the surrounding heat. 2 type heat in set A. 2 type heat in set A. So, by set B, to find out the mass ice melted due to heat from surrounding only. To find mass of ice melted due to heat from surrounding only. Okay, question number 3. What are the sources of the latent heat absorbed by the ice in experiment set A? Set A. In set A. So, what are 2 sources? What are 2? Question number 3. Question number 3, I think so. Question number 3. Okay. I think question number 3. Okay. 2 sources. 2 sources. Heat from surrounding. Heat from surrounding. Second one, heat from heater. Because the heater is connected to electricity. So, heat from surrounding, heat from heater. So, heat from surrounding, heat, 2 sources. This source, 2 sources. So, the ice melt because of ice melts in set A because of heat from surrounding and heat from heater. Okay. Next question. Question 4. In set A, what is the mass of ice melted due to heat absorbed from heater only? Okay. Mass, okay, based on description, mass of ice collected in set A after 2 minutes is 38 gram. 38 gram. This one 38.0 gram. Okay. This one heat from surrounding only. Heat from surrounding only. So what is the mass? Mass ice collected in set B after 2 minutes is 6 gram. 6.0 gram. So this heat from surrounding set A, heat from the heater combined together, 38 gram ice melted. Ice water. 38 gram is melted. But heat set B, control set, heat from surrounding only 6 gram. 6 gram. So what is the mass of ice melted because of heater only? That's why they want to find out the mix together now. Okay, the ice melt mix together. Ice melt because of heat from surrounding. So mix together, 38 gram. So they want to find out what is the ice melted due to surrounding heat only. That's what I said. Surrounding, because it's not connected to heater, the heater is not connected to electricity. So surrounding heat from surrounding heat only. So 6 gram. So what is the total mass? What is total mass? Part 4. The mass inside A, what is the mass of ice melted due to heat absorbed from heater only? Heater only 38.0 minus 6.0 is 32.0 gram. This is the ice melted due to heater only. Ice melted due to heater only, 32 gram. So to find out, that's why they put control set. Because they set A, they mix together. Ice melt, some ice melt because of heat from surrounding. Some ice melt because of heat from heater. So they mix together 38 gram. So they want to find out heat from surrounding only how much. So 6 gram. Heat 6 gram. So 38 minus 32.6 gram. So that is the ice melted due to heater only. Question number 5. Question number 5. Calculate the electrical energy produced by heater during 2 minutes. So electrical energy. Question 5. Electrical energy, the formula. Electrical energy, the formula is power times time. Power multiplied time. What is the power? 96 watt. And the time is 2 minutes. 2 times 60. So what is the heat energy? Sorry, the electrical energy. I don't know. Maybe I've answered. Okay. Okay, 1000. Okay. This is the electrical energy. Electrical energy formula, power multiplied time. Power 96 watt. And the time 2 minutes interval. Time 2 minutes, 2 times 60 seconds. So 11,520 joule. 11,520 joule. Okay. Next question. Next question. Determine the specific latent of fusion. Specific latent of fusion. Determine the specific latent heat of fusion. Question 5. Okay. Question 5. Okay. Question 5. Okay. Electrical energy equals to latent heat energy. Latent heat energy. Electrical energy is found as now 11,250 joule. And latent heat energy, the formula is ml. ml. So the m is the mass. The mass ice melt, because this now electrical energy find by heater. The heat energy for heater. So the ice melt also must be heater. The ice melt because heater is 32 gram. So 32 gram is changed to kg 0.032. Mass. And L, we don't know. The latent heat of fusion, we don't know. And 11,250. 11,250. So the ice melt 0.032. Ice melt because of heater only. Heater is electrical energy. So 0.032. It's not 38 gram. It's not 32 gram only. 0.023 L. L means okay, later heater. So 11,250 0.032. The L equals to L equals to I don't have the answer, but you can find the answer. L. You can find the answer. L. You can find L. What do you call it? Okay, it's 11,250 and 0.032 divided by 0.032 L. Okay, next question. Okay. Next question. Okay. Okay. The specific latent heat of fusion of water and specific latent heat vaporization of water are given in the below. Explain why heat energy needed to change a substance from solid state to liquid state at constant temperature. There's no change in temperature. So that latent heat of fusion. Latent heat of fusion means solid change to liquid without change in temperature. Solid change to liquid without change in temperature. Okay, why we heat energy needed? Why heat energy needed? The heat energy needed, heat energy, how the heat, we supply the heat at latent heat or room temperature is constant, heat absorb, but at temperature, constant temperature or temperature no change. That is called latent heat of fusion. So latent heat or latent energy is needed to overcome forces of attraction between molecules and to break the bonds so that solid can turn into liquid. I repeat answer. Latent heat energy is needed to overcome the forces of attraction between molecules and break the bonds so that the solid can turn into liquid. Okay, heat energy is needed. Heat energy needed. The heat energy absorbed, but there's no change in temperature. So that time, the force of attraction between molecules, solid molecules. So the what do you call it? They break the bonds. Solid to become liquid. Solid to become liquid. To break the bonds or to overcome the forces attraction. Force attraction is solid. This force attraction is so strong. So to overcome the forces attraction. To overcome the force attraction so that the solid molecules or atoms can become liquid molecules. So to overcome the force attraction between molecules, solid molecule, the forces attraction is so strong. So to overcome the force attraction between the molecules, solid molecules, you need energy, the latent heat energy. The heat energy is supplied to break the bond to overcome the force of attraction. Okay, and second question. Explain why specific latent heat vaporization of water is much larger than specific latent heat of fusion of water. Okay, you can see this one. Specific latent heat of fusion is 3.3 to 10 power 5. Specific latent heat of vaporization 2.2 to 10 power 6. So 10 power 5 only, 10 power 6. So vaporization, we need higher energy. We need higher energy than fusion. Latent heat of fusion compared to latent heat of vaporization. Latent heat of vaporization, high energy. That is high energy. Why? I will give the answer to you, then I will explain to you. Specific latent heat vaporization is higher because higher energy is needed to push against atmospheric pressure and venture into largely increased volume of air. Again, specific latent heat vaporization is higher because higher energy is needed to push against atmospheric pressure and venture into largely increased volume of air. Okay, what is the meaning of this one? This one, solid melt become ice water, solid become ice water, ice become ice water. So solid become liquid, or that we call it latent heat of fusion. But this liquid take the container, the shape of the container. The liquid take the shape of the container, but this liquid turn into steam. Steam is latent heat of vaporization. So the molecules turn into steam. The water molecules, liquid molecules, turn into steam or gas. So the molecules have to escape from the water. So escape from water, there's one resistance, restriction. So that is called atmospheric pressure. So the molecules which escape from the water become steam. The molecule which escape from the water becomes steam or become gas. The molecules push against atmospheric pressure. So push against atmospheric pressure. So the enough energies must have enough energy. So the latent heat of vaporization is higher. Okay, carry the energy. Latent heat vaporization, higher energy is needed. Higher energy needed for the molecules to escape from water become steam by pushing against the atmospheric pressure. The pushing against atmospheric pressure, pushing against. And the molecules venture into largely increased volume. Increase volume. So in atmosphere, the molecule from water must have enough energy to venture into largely increased volume of air. Okay, but this one is not much energy because the ice solid become ice water is take that container shape only. They take the shape of the container only. The water will take the shape of the container only. But this water becomes steam. So steam, two problem. One, the molecules in order to escape, it must push against atmospheric pressure. Atmospheric pressure pushing down. So if not enough energy, if the molecules having not enough energy, latent heat of vapor is not enough energy, so the molecule come down. So the molecule to push against atmospheric pressure, it need higher energy. The molecule escape, higher energy, higher latent heat vaporization, higher energy. So higher energy, needs higher energy to push against atmospheric pressure. Then and also the molecules venture into a largely increased volume in the air. Because this is container, small container. But this one, the molecules going to steam going to go everywhere. The steam going everywhere. So the steam going to a largely increased atmosphere pressure, atmosphere area, or the volume, largely increased volume, the air. So the energy must be higher energy. So it means higher energy need to increase. It must venture into largely increased volume air. You understand? Okay. First of all, atmosphere pressure push against. So secondly, the steam going to go everywhere. So the must have enough energy. So higher vaporization. Okay. Next question. Explain why the space. Okay. Question: how much heat energy is needed to convert 1 gram water at 20 degrees Celsius to steam at 100 degrees Celsius? Okay. The one is question number 3. Question number 3. Explain the specific. How much heat energy needed to 1 gram water at 20 degrees Celsius at steam? So this water must change to this 20 degrees Celsius must change to 100 degrees Celsius. The water must change to temperature 100 degrees Celsius before it boils. Before boils, becomes steam at 100 degrees Celsius also. So how many stages? 2 stages are there. The first stage, 20 to 100. Increase, the temperature must increase to 100. So this one is called heat capacity. Once reach heat capacity 100 degrees Celsius, then the water starts to boil. Become steam at 100 degrees Celsius. So there's no change in temperature. However, change in state of matter. Water becomes steam. Water becomes gas. Liquid becomes gas. So latent heat, vaporization. Latent heat vaporization. Two stages. The first stage, 20 degrees Celsius to become increased temperature of 100 degrees Celsius. Okay. And 100 degrees Celsius, the temperature remain constant, becomes steam. So Q equals to MC theta and ML. So this is 1 gram. 1 gram is a 0.001 gram, 0.001. Okay, this one 0.001. Okay, 0.001. Okay, 0.001 gram. And C, specific heat capacity water. Specific heat capacity water is 4200. And theta, the change in temperature, 20 become 100. 20 become 100, change in temperature 80. Okay, plus ml. Again, 0.00, I think must be 0.001. 0.001 L. L means specific latent heat vaporization. Specific latent heat vaporization. The answer is given to the answer is this one is given. The data given 2.26 and 10 power 6. If you times this one, you get Q equals to 2596 Joule. 2596 Joule. Okay. Heat capacity. Heat capacity means change in temperature. 20 become 100. 100 boil. 100 boil becomes steam. So two stages are there. So first stage, heat capacity. Heat capacity. Second stage, latent heat vaporization, because water boil become steam. Okay. And 2496 lah. Okay. Next question. Next questions. Okay, next questions is question number 4. How much heat energy needed to convert 1 gram ice at 0 degrees Celsius to water at 8 degrees Celsius? So, ice 0 degrees Celsius. Ice melt become water at 0 degrees Celsius. Ice melt become water at 0 degrees Celsius. And not only that, they changing temperature to 80 degrees Celsius water. How much heat energy to change ice at 0 degrees Celsius to water at 80 degrees Celsius? So water 80 degrees Celsius. So how many stages are there? 2 stages are there. The first stage, latent heat of fusion. Latent heat fusion. Latent heat of fusion, because ice melt become water. Ice melt become water. Ice melt become water, and the water, ice melt become water. Ice become 0 degrees ice cube, 0 degrees ice water. Same, ice melting temperature ice 0 degrees Celsius. But it's not stopping there. They want the temperature to increase, temperature 80 degrees Celsius. So the temperature increase. So the heat capacity. Heat capacity. Heat capacity. So the formula Q equals to ml plus mc theta. The m equals to 1 gram, 0.001. L means ice become water, solid become liquid. So latent heat of fusion. Latent heat of fusion 3.36 times 10 power 5. I think so. Okay. 3.36 times 10 power 5 plus the m equals to 0.001. The same heat energy, the continuous temperature increase. Continuous mass, same mass, 0.01, 0.01, same mass, 1 kg, 1 gram now, 1 gram. And C means 4200. 4200 specific heat capacity water. And theta 0 to 80. Difference temperature is what? 80 degrees Celsius. 80 minus 0. So 80. So if you do that, we got Q equals to 672 Joule. 672 Joule. Okay. I will end up today lesson today with this, but I will continue with the questions, objective questions, and some more lessons. And we're going to see you soon, lah. We're going to see you soon. But the Form 4 class, I think I will continue doing online. But the Form 5 class I will do teaching lah, because the Form 5 class they open up the Form 5 class Form 4 class maybe online, but this month we don't know lah. Next month we maybe the open Form 4, so we will do open for Form 4 also. And thank you very much for listening to me. Okay.